Today we're going to learn how to reuse code in Python. Specifically, we're going to explore how we can use functions and modules to help us, as programmers, stop reinventing the wheel. People from all walks of life program, but despite the diversity amongst programmers, they share something in common. They have a deep-seated desire to not reinvent the wheel. A good programmer believes to his or her core that whenever possible, they should write code once and use it often. Heretofore, we haven't really discussed this philosophy of reuse, but today you will learn exactly how to live up to this mantra. This begs the question, however, what does it mean to write reusable code? In reality, it is a fairly simple process. You first must be on the lookout for tasks that you perform time and time again in your programs. Once you've identified something you do over and over again, you will separate the code that performs that task out into something we call a function. We will talk more about functions in a moment, but for now, just understand that functions are kind of like programmers' version of Legos. We can use pre-existing functions to assemble larger programs together, similar to how you might create something awesome using pre-existing Legos. You've probably dealt with functions in one or more of your math classes before. In reality, there are a lot of similarities between the functions you deal with in math and the functions you deal with in programming. They both can receive input and perform useful computational tasks. They both can perform calculations and produce results as output. They even share a common syntax, such as the use of parentheses and variables that define parameters that can be passed to the function and so forth. It is important to understand, however, that functions in programming can do far more than mathematical calculations. The truth is, you already use functions in your programming. Heretofore, we have used print to output data to the screen, type to determine the data type for a particular value, and input to prompt the user for input. Whether you are using built-in Python functions like these ones, or writing functions of your own, a function is nothing more than a series of commands organized together that does a single thing. A function is a named chunk of code that does something meaningful, returns a value, or both. In this example, I have a two-line program. The first line declares a variable with the identifier name and is currently assigned the value of James, a string. The second line does what we refer to as a function call to a function named greet. Above, I show you the code that was used to define the greet function. The greet function is a simple function that takes in a single value from the caller and prints it out to the screen after prepending the text hi. In programmer speak, the second line of the code calls the greet function, passing it the value of the name variable. You will notice that name is placed within parentheses that follow greet. When you call a function, any values you provide are said to be passed to the function. In addition to data, you are passing control over the program to the function as well. What this means is that the function's code must finish executing before the next line in your program can be executed. To pass control to a function essentially means that you have to wait until it is done and passes control back to you. Let's dig a little deeper into how to create or declare a function. And then we will code a couple of examples, hands-on. When creating a function, you begin with the def keyword. This indicates to Python that you are defining something. Next comes the name of your function, then parentheses and a colon. Finally comes an indented statement block that should contain the logic of your function. What it does or accomplishes goes here. The first line of the function, up to and including the colon, is called the function header, and the rest, the indented statements, comprise what's called the function body. Let's take it a little bit further. What if you want to create a function that receives input and/or that returns data? Any data you want the function to receive goes within the parentheses. Items of data that a function can receive are called parameters. The parameters that a function can receive are listed in a comma-delimited list called the parameter list, placed within the parentheses. A function does not have to have parameters. Regardless of whether a function has defined parameters, however, the parentheses must always be listed, even if there is nothing in between them. Any data that you want to return from the function must be specified using the return keyword. Once Python encounters the return keyword in a function, it will automatically pass the indicated value as well as control over the program back to whoever called the function. In programmer speak, the person who executes or calls a function is known as the caller. Time to write a simple function. We are going to write a function named bark. Bark will be a simple function that simply prints woof to the screen using Python's built-in print function. Notice in the code that we create the function and then we call it later on. In this example, we call it from a loop 3 times. This is an example of a simple function that merely does something. It neither accepts nor returns data of any kind. Okay, let's write a program in which we create our first function. I'm starting from idle at the shell at the interactive console, and I'm going to create a new file for my program. File, new file. Okay, I'm going to go ahead and save this now by going to File, Save As, and I'm going to go ahead, put this in my Colstock code Python projects directory. I'm going to call this one lowercase bark.py. We're going to be creating a function called bark and then calling it just to get some practice. All right, awesome. First thing I'm going to do, put in a comment that says what I'm doing. I'm declaring a function. To declare a function, you use the def keyword followed by the function name and then parentheses and a colon. So I'm defining bark. It doesn't take in any arguments. And then when someone calls my bark function, I want it to woof. So I'm just going to print out to the screen, woof. All right. When you create a function, you create it and then you refer to it. Now that I've defined my function, I can actually use it. I'm going to start off by printing to the screen, who let the dogs out? And then I want to woof 3 times. So to do something over and over again, we use a loop. In my case, I'm going to use the function in my code by using a loop. I'm going to use a for loop, and then I want to repeat the same code 3 times because I want it to say, who let the dogs out? Woof, woof, woof. So all I have to do is call the function. Bark. It's that simple. Let's go ahead and save our program. You can do File Save or Control S, and then we'll go to the Run menu and let's see how it works. So it ran our program and it printed to the screen, who let the dogs out? And as you can see, my loop executed 3 times. That's what this range 3 thing right here does. And so 3 times. So if you want to do something 3 times, you use range 3. As you can see, I define my function. This is a simple function that just does something. It's called a void function. And then I use it down below in my code. Time to write a more complex function. We are going to write a function called degrees. This function will calculate the sum of the internal angles of a polygon, given the number of sides. If you weren't already aware, you can find the sum of the internal angles of any polygon by subtracting 2 from the total number of sides and then multiplying that number by 180. It works every time. Notice how there is one item in the parameter list of our function named sides. This value will be provided or passed in by the caller. The function simply returns to the caller the sum of the internal angles of the polygon by applying the formula I just mentioned. As always, I define the function first, and then it is available to be used later on in the program. In this case, I call degrees from a loop. The loop uses degrees to figure out the sum of the internal angles of polygons with sides of 3, 4, 5, 6, 7, and 8. Now let's write a slightly more complex function. This function is going to be called degrees, and I'm going to show you how you can create a function that takes in information and passes information back. So let's go to File, New, File. Now let's go ahead and save our file. Go to File and choose Save As. I'm going to go to my code, Python projects directory. I'm going to call this one degrees, all lowercase. .py. Okay, now it's time to write our program. The first thing I want to do is include a comment. What we're going to do is we're going to declare our function first, and then we're going to use it later. The function that we're creating is called degrees. Remember, when you create a function, it starts with the def keyword. because you're defining something new. The name of our function is degrees, and it has one parameter called sides. Callers can pass one argument, and this sides argument will represent the number of sides in their polygon. Now we are in the function body, so we need to write our code. The first thing we're going to do is use a return statement, and we are going to subtract 2 from sides and multiply it by 180. Remember, this is the formula for figuring out the internal angles, the sum of the internal angles of a polygon. So we use the return keyword, we subtract 2 from whatever sides value was passed in, and then we multiply it by 180. So for example, if somebody passed in 3 sides, the number of sides in the triangle, we would subtract 2 from 3, which would give us 1. 1 times 180 is 180. And as you guys know by now, the sum of the internal angles of a triangle is 180, and that's how you get it. Now down below, we are going to go through a loop, and we're going to print out to the screen before we do that sum of internal angles. We are going to use the function over and over and over again. We're going to call it over and over again to determine the sum of the internal angles for polygons who have a number of sides between 3 and 8. So next thing we're going to do, let's put down a comment. Remember, you declare a function and then you use it in your code. We're going to create a little loop, a for loop. Just like before, I'm using this special range thing. In this case, I want to loop for the numbers 3, 4, 5, 6, 7, and 8. 9 is the upper boundary, and it is not included. You'll see I have an iteration variable here called s, which will store the number between 3 and 8. Now I'm in the actual body of my for loop, so I need to write some code. The first thing I'm going to do is create a variable called d, and I'm going to assign it whatever value comes back from the call to degrees. So what I'm doing here is I start with 3, and then I call degrees, passing it 3 sides. Then it returns the sum of the internal angles, and I will print it out to the screen. As you can see, the last line in the indented statement block is a print function. Notice how I have to cast some of the values to a string. Let's go ahead and save this, file save, or Control S. And once we run it, I think you'll have a better understanding of how it works. As you can see, I was able to run the program. It first printed out sum of internal angles, and then it looped through the numbers 3 through 9, not including 9. So the iteration variable s first had the value of 3. The value of 3 was passed to the degrees function. The function came up with 180, and that was assigned to the variable d. And then I simply printed that out to the screen. Then it went back through the for loop again, through another iteration, and chose the number 4. 4 was passed to the degree function, which returned 360, so forth and so on. So this is a perfect example of how you can create a function that takes in an argument and also returns back something. So this is what we call a fruitful function. The examples we just explored demonstrate the 2 major types of functions, void and fruitful. Some functions just do something and do not return anything to the caller. These are referred to as void functions. I think of these as black holes where stuff goes in and heavens knows what happens with it. When dealing with void functions, there must be trust between the caller and the function that whatever was supposed to happen, in fact, happened. Python's built-in print function is a perfect example of a void function. It just outputs whatever is provided to the screen. It doesn't really pass anything back. On the other hand, so-called fruitful functions are like trees that bear fruit. These functions yield some sort of result that is passed back to the caller. In many cases, these functions return the results of some sort of calculations or data processing. Python's built-in input function is a perfect example of a fruitful function. You provide it with a message to prompt the user, and then it takes whatever the user typed in and passes it back to you. It is important to remember that functions must be declared following the same naming conventions and rules as when defining other things, like variables in Python. Function names may include letters, numbers, and certain valid punctuation. Like variables, function names cannot begin with a number, and you cannot define a function with a name that conflicts with a Python reserved keyword. In terms of terminology, remember that the first line of a function is called the function header and the rest is called the function body. Speaking of slang, programmers throw it around just like you. Here is some more terminology to look out for. When you execute a function from somewhere in your code, you are said to be calling it. In programmer speak, you are the caller of the function. When you provide data to a function, you are said to be passing values in. And perhaps most confusing is the fact that the values you pass in are known as arguments. But the inputs that a function is defined to accept are commonly referred to as parameters. Just try your best to follow along and you will be talking the talk in no time. Functions are great, but it is the use and creation of something called modules that will really take your code reuse to the next level. Modules are collections of related functions and other definitions. They are normally placed in a single file, and I like to think of them as books of code, each book containing functions with a similar subject or theme. To use a module, you use the import keyword, followed by the name of the module that you want to include in your program. Once you have imported the module, you will be able to use it by referring to it in your code. There are innumerable modules out there, but most Python programmers begin by using common ones such as math, random, and OS. Time to get some practice by writing a simple program that uses a module. In this program, we import the math module and then use its fsum function to add a list of numbers together. First, we import the module, and then we use it later on in the code to do arithmetic for us. Notice how the call to the function we are using from the math module, fsum, is prefixed by the name of the module, math. Now I'm going to show you how to use a module in one of your programs. Writing your own functions is great, but using a pre-existing module and its functions that are already written is much, much better. So we're going to create a new file. We're going to go to File, New File. Okay, now we're going to save the file. Go to File, Save As. I'm going to put this in my code, Python projects directory. This one we're going to call fsum, all lowercase, fsum.py. That stands for float sum. So basically when you want to add numbers together that aren't integers but that have floats, we're going to use fsum. And we're going to use a function called fsum from the math module. So we're going to go ahead and save that. First thing I want to do is make it really clear that I'm importing the module into my program. The module that we're going to be using is a really useful one called math. Remember, if you want to bring a module in, you have to use the import keyword. So I import math. Now I'm going to create myself a variable, a list of values. Because what fsum does is it takes a list of values and sums them all together. It's a very useful thing to be able to do. So I'm creating a variable here called values, and I'm assigning it a list that has 4 values. Notice how some are integers and one of them is a float. Now I'm going to sum all these values together using fsum. Fsum is not a function that I've written, it's a function that is in the math module. When you want to use a module, you import it and then you can simply use any of its functions by prefixing the function name with the name of the module. So here, I'm creating a variable called results, assigning it whatever comes back from my call to math's fsum function. So notice how math, the name of the module, prefixes the call to the function. Fsum is the name of the function and it takes one argument, a list of values. So what I did was I created a list of values and I passed it to the math module's fsum function. Whatever comes back from that, I'm going to assign to this results variable. And last but not least, I will print that out to the screen. So instead of summing all these numbers together, however big the list is, I just pass it, use my math function, and it does all the arithmetic for me. Let's go ahead and save this. You can go to File, Save, or Control S, and then run the program. Go to the Run menu, or you can just press F5. As you can see, what output to the screen was the result of the fsum functions summing up the numbers 1, 2, 3, and then the fractional value 0.9999999. This is a perfect example of how you can use a pre-built module. You simply import and then refer to it in your code. Notice how the function that I call, the one that I want to use, is prefixed by the name of the module. Let's try another program. This time, let's write a simple program that simulates rolling a 6-sided die. To accomplish this, we need to use a function from the random module. Again, we first import the random module utilizing the import keyword. Then we use the module's randint function later on in our code to generate a random integer between 1 and 6. As before, we prefix the call to the fsum function with the module's name, random. As you can see, using previously written code is as easy as import and then code. Let's create another program that uses a module. We're going to call this one roll the die, and it's going to generate for us a random number between 1 and 6, just like if we were rolling a single 6-sided die. So let's start by creating our program file. Go to File, New File. Now let's save our file. Let's go to File, Save As. I'm going to put this in my Colstock code Python projects directory, and I'm going to name it all lowercase roll the die.py. Save. Okay, we are going to import what's called the random module. This module has a bunch of functions and definitions in it that make it easy for us to generate random numbers. So remember, the first thing we need to do is import our module. Once we have it imported, then we can use it. We use the import keyword followed by the name of the module. In this case, we're importing a module named random. Next thing we're going to do, declare a couple of variables. We're going to use these variables to limit the range of the randomly generated number. We need to tell the function we're going to use what's the minimum number it can generate, what's the maximum number that it can generate. You'll probably notice I'm doing something a little different here. If you want to declare more than one variable on a line, you can just separate each one, delimit them with a semicolon. So I have two limit variables. One is called min and one is called max. Pretty logical. I don't want to generate a number lower than 1, and I don't want to generate a number greater than 6. So we are going to roll the die. To roll the die, we are going to use one of random's functions called randint. Okay, so there's a lot here. First thing I'm doing is I'm declaring a variable called results, and then you'll see the assignment operator. I am going to make a call to the randint function. The randint function returns a random integer between whatever minimum and maximum you specify. So I am passing two different arguments to the randint function, min and max. Min is 1 and max is 6. The randint function will return a random number, and I will store that in my results variable. And that leaves just one last thing to do, which is to print out the results. So I am using Python's built-in random module and its randint function to generate a random number for me between 1 and 6. And last but not least, I print that out to the screen. So let's go ahead and save this, File Save or Control S. And then to run it, we can just press F5 or we can go to Run Module, F5. As you can see, this generated a number 3. If I would run it again, 3, 4, 4, 1, 3, 6, 4, 2. So just like rolling a die. So this is another example of a module that you can use in your programs so that you don't have to write more code.